chain ganglia. They're showing this one moving down, and then we've got an area of synapse and the ganglia. So this pre-fiber, represented in green, synapse on the red and carries on to the target organ. Everybody follow me? Now let's take a peek at the second fiber. This second fiber, once again, leaves by way of the spinal nerve, does a turn, still travels, it doesn't synapse, travels through the chain ganglia, leaves by way of something called the splanchnic nerve. Where did it make its way to? Do you happen to remember what term, or do you happen to remember in the picture what those were? If you look at this picture right here, do you remember how in the traveling from the first picture that we looked at, some of it went to these collateral ganglia that are located in the areas of the abdominal cavity? This one is traveling by way of the splanchnic nerve, which is an important one, into one of these collateral ganglia. That entire fiber that we just traced is pretty long. That pre-fiber is pretty much a good long fiber and made its way all the way to this collateral ganglion before it's synapsed. So the pre-fiber makes its way, it synapses, and the post goes on to its target organ. So far, the two routes that I've looked at, one of the routes got to travel the chain ganglia, one of them made their way to collateral ganglia.
What's the purpose of having three fibers synapse instead of just the one long fiber?
Hold on to that thought, because it's going to deal with the fact that this is our sympathetic division. Because the sympathetic division's job is to make things sort of ramp up. So we're going to be dependent on these fibers and their neurotransmitters that they release. But hold on to that thought. Now let's look at the third one. So the two routes, one traveling up and down the chain, one not synapsing in the chain, going to a collateral ganglia. The third route, let's take a peek. Let's follow the fiber, follow the fiber, follow the fiber. Once again, by way of the rami. And then this one, boom, synapses right there in the chain. And then its post fiber exits by way of a spinal nerve to go to the areas of the body it serves. Do you see how the areas of the body are different in the little pink? Okay. Now the fourth route. On the fourth one, once again, make a turn, this time traveling up the chain ganglia, synapsing in a ganglia, making its way with the post fiber to its target. So traveling up or traveling down is going to serve that area of the body. So does that kind of make sense now for this picture? Okay, so these are the different routes that can be taken. Those routes that we're going to get. Now remember, sympathetic division. Sympathetic is for preparing the body for fight or flight. So, this right here is what I just showed you in the picture. These are our routes that those pre-ganglionic fibers can take before synapsing with the post. Any questions so far?
Just one more, and this may not even be important, but when you're talking about the pre-ganglionic neuron exits the way of the spinal nerve, so it's not necessarily like, it's just kind of like, it's exiting the same area, and they're not like attached, or it doesn't go through it.
It's a totally different fiber.
It's a completely different fiber, separated. Okay.
Well, let's change our terminology.
Okay.
Let's call it the axon.
Okay.
So, if we go back and think about the peripheral, which would go to our, let's go back and think about the fiber, the axon that would go to our stuff out here, okay? That axon would be coming from this area. Yeah. So these axons are coming from the lateral horn. And it's on both sides.
Yeah.
Even though we just looked at it from the one side, this is happening on both. It's happening on both sides. Does that help?
Yeah, that's all that's fine.
Okay. So, when we begin to look at this, all right, and the fiber, let that kind of signal, like we just said, let that signal axon. All right. Let that also let you know it's an axon. So, those axons leave by way of the different routes and go to their target organ. We do have the one route, which Brian was just asking about, okay, where it left by way of the spinal nerve. They call that one the spinal nerve route, because that axon, remember, if this is the sympathetic division, which is preparing the body to do that fight or flee, it has to prepare those skeletal muscles for that activity. That's why the spinal nerve route goes to the skeletal muscle. Does that make sense? Because if I need to prepare that skeletal muscle to do the fight or the flee, that means I need that muscle to be ready to act. And this is what's happening by way of the spinal nerve. Okay? Everybody with me? Even though it's autonomic, it still makes its way to the skeletal muscle. Well, I think I mentioned this, because it shows the different areas that are getting served. Note, they're trying to let you know that depending on whether you travel up the ganglia or down that chain ganglia, they're going into the areas of the body that they serve. So if we look at our picture where it's showing this right here, okay? If you look at that picture and they have our pre-fibers, if I have to travel up the ganglia, it's servicing areas that are in the upper thoracic region into the arms, neck, and head. If it travels about midway and down, it's serving things in my abdominopelvic region. Does that kind of make sense now when you look at that picture? Okay. So it's amazing, everything that gets innervated. For example, you're going to have little muscles in your eyes that are innervated by the fibers so that your pupils can dilate and let more light in.
When you say innervated, is that you just meaning like command, information exchanging, that
That's
kind of
where the synapse is taking place. The synapse is taking place on that muscle of the eye. And actually at the pupil. Pretty cool. Okay? Any questions so far? Still on the sympathetic division. Haven't moved into the autonomic yet. Once again, that splanchnic nerve. Everybody notice that when I pointed it out? Okay? That splanchnic nerve, okay, allows to go to collateral ganglia. This just simply means we don't synapse in the chain. We synapse in the collateral ganglia. And the post fiber makes its way to the target organ.
So what's that nerve? It's just the way.
It's just like a big nerve that if you look at the structure of the chain, it looks like a big nerve that's just running off of the chain. And we've got 3 of the collateral ganglias, and they just make their way to a collateral ganglia and allow for the synapse. If you look at this picture right here, they try to show the collateral ones by really huge ganglia. And then if you go back to the original picture, this one right here, they show them existing right there, giving you an idea of where those collateral are found, because they have names: inferior mesenteric, superior mesenteric, and so forth. So they do have the names. Now, when we look at those collateral ganglia, and go back to this picture right here, this one that we're looking at, and see how we've got the celiac, the superior, and the inferior, okay? Now, if you trace those red fibers, do you kind of see how, like, maybe the celiac goes to certain organs, inferior, superior goes to certain organs, okay? Now, the network that's getting created by these 3 ganglia, we call it the abdominal. Look at where we are. We're in the abdominal region. Aortic, because if you look at this picture, what vessel do you see the really huge bumps on? The aorta. This is my abdominal aortic, and because there's a grouping of something, plexus. Like it shows in the picture, my celiac, superior, inferior, mesenteric, okay? Remember how I mentioned that one of them could be referred to as the solar plexus, all right? If you get hit in that area really hard, okay, basically it kind of knocks you out, all right, kind of takes you down because of what it innervates. It's a collective name for my celiac and my inferior, the top 2. If you take a peek at the top 2 and look at what they innervate, gives you an idea of why getting hit in that region can take you down. Because you are automatically affecting those organs. They are almost, they're getting a